All right, so something I didn't realize was on Moodle, all the assignments and labs were from last semester. At least they were pointing to the directions from last semester. So those weren't necessarily the ones I wanted you all to do. As a result, come week 8, I believe, is the makeup week. So on that, at that time, I'll let you make up all the assignments up to this point, assignments and labs for full credit. And that was just because it was my bad. I had the wrong ones. I had it pointing to the wrong lab and assignment direction. So I fixed it now. And like I said, makeup week, I'll let you all make up those assignments and labs for full credit. All right. And I did want to, before we get started, just remind you all here are here on time. But if you come after 5 minutes, you are marked as absent. If you come between 10 and 10:05, you're marked as late. So make sure you come on time from here on out. All of you are here on time, but somebody just came, so they're going to be marked as late. Another thing, you all right now aren't doing it, but I've seen it before and I've seen it in my other classes. But make sure that you all are sitting up straight while you're in this class and not laying down in bed, and at least act professional, look the part. If you want a, recommendation from me, if you want a, for me to put your name in the pot for whatever job and opportunities are out there, you have to show me that you are indeed professionals and that you indeed do take this class seriously. So, like I said, right now nobody is doing it, but I've seen it before. Just laying down and not sitting up in class, that's a problem for me. Plus, another thing, if you fall asleep in class, I will boot you. I'll just kick you out. All right. I don't have time to waste teaching somebody who is not conscious. So going forward, if you do fall asleep in class, I will boot you from class. So again, nobody is doing it right now. I don't think anybody is susceptible to doing it right now. But just going forward, if you do fall asleep, I will boot you. All right. And then lastly, again, I haven't caught anybody doing this yet, and all of you have heard my, spiel, I guess, if you will. But plagiarism is not tolerated in my class. If you do plagiarize, it will be a 0 on the assignment. If I catch you again, you will fail the entire course. So just don't plagiarize. And again, haven't caught anybody in this class doing that. And nobody right now is doing any of the things I've discussed. But in my other class, it's an issue. And I'll be addressing them later as well. If you have any questions or aren't clear or anything I've said, let me know. All right. All right. Well, let's keep going. All right, so lecture 7, and again, I won't be reviewing assignment 4, lab 4, not right now. I'll review those come makeup week because I'm giving you the opportunity to make those up for full credit. Okay, so I won't be reviewing them right now, and I probably will be taking down the other reviews I've put up so far.
When is makeup week?
Week 8, which is I think 2 or 3 weeks from now. So this week and next week we have more lectures. The following week after that will be midterms. And I believe the following week after that is makeup week, and I'll just confirm with you. So we're on week 5 right now. So week 6, week 7, and then we have makeup. And if you notice, we have a couple wellness days in here as well. So our next wellness day will be not this Friday, but the Friday after next on March 5th. And then that following Monday will be the midterm. And the midterm will cover everything that we've done up until this point. All right. After that week, which is week 7, will be makeup. And at Monday, March 15th, will be a wellness day as well. So really, you have this whole week to make up any assignments and labs. Not regarding, up until week 4. So lab 5, assignment 5, lab 6, assignment 6, and lab 7, assignment 7. If you don't do those at that time, they will be half credit during makeup week. Okay. So anything up until week 4, I'll give you full credit for. If you miss anything from now on out, it will be half credit. All right. All right, let's go ahead. Go on to the lecture. So again, this class, more so than programming 1, this class, programming 1 is about learning just basic fundamentals of programming, how to get started, how to write your first program. In this class, we're learning the actual concepts of object-oriented programming. And you'll hear me say that term over and over again, so make sure you're familiar with that term. Object-oriented programming means that we have classes and we have objects. We can use objects to represent a class or to build an instance of a class so that we can use that instance in our programs. For example, last week we did the automobile class. So we build the automobile class, then we create objects of that class, and we can manipulate them and change their data values and get their data values within our program. All right, so again, I'm going to drill into object-oriented programming. If you don't take anything else from this class, at least know object-oriented programming and then the 4 pillars of object-oriented programming, which we'll talk about another one. The first one we've talked about was, I forgot what was it? Encapsulation. So that was the first one we talked about, where we have getters and setters, and then we have all of our class variables private and public getters and setters to access those variables. All right. So that was the first one we talked about. The next pillar we'll talk about is inheritance. And if you think about inheritance, it's exactly what it sounds. One class can inherit from another. So again, inheritance is a pillar of object-oriented programming, right? It's one of the 4. The first one we talked about was encapsulation. The next one now is inheritance. We can inherit attributes and methods from another class. So when we inherit, that includes class variables, any getters and setters we have, any constructors, and any other methods that are in that class. It inherits everything, okay? So a little light bulb or object-oriented programming. So here's just a quick diagram of what object-oriented programming would represent. Right? So for example, we have a vehicle class or a vehicle, right? From there, automobile inherits from vehicle. Automobile, then car inherits from automobile, right? Car is a type of automobile. Automobile is a type of vehicle. If you look over here, a pooled vehicle is a type of vehicle. A rickshaw and a cart are a type of pooled vehicle, right? Each one of these is a type of its parent class. So we think about a adult and adult's children. A child inherits from the adult, right? And so on and so forth, all the way down like a family tree almost. Or you think about a lot of objects. Say, for example, we have a tool, right? From tool, a hand tool is a type of tool. Then a screwdriver is a type of hand tool, so on and so forth, right? So we can use inheritance to represent a more general class, and they get more specific as we go on down. So this, again, a real world example. A child inherits from its parents, right? However, more so than a parent, right? If, for example, a child inherits everything from their parent, hopefully, you know, they have additional characteristics as well. They can run faster. They can jump higher. They can code better, whatever it may be. A child would inherit all the characteristics from their parents and then have additional attributes as well on top of that, right? Which makes them, you know, more efficient or better, hopefully. So in programming, we have a similar kind of relationship where we have a parent and a child. Instead, we have a superclass and a subclass. So we go back to this example. Vehicle would be a superclass of pooled vehicle. Therefore, pooled vehicle would be a subclass of vehicles. So on and so forth. Rickshaw is a subclass of pooled vehicles. Again, pooled vehicles is a subclass of vehicles. Bus would be a subclass of automobiles, and automobiles would be a subclass of vehicles. If we look at it the other way, vehicles is the superclass of automobiles, where automobiles is a superclass of car or bus. All right. So just like we have the parent-child relationship in the real world, we have the superclass subclass relationship in programming. All right. The superclass again acts as the parent, and the subclass acts as the child, where the subclass inherits everything from the superclass, including the superclass constructors. All right. So how do we actually say that we want to inherit from another class? We simply use the extends keyword in our class declaration. So when we have our class, public class automobile extends vehicle, all right? So that's how we tell the compiler that we want to inherit from another class. We use the extends keyword. So if you see here, I've created the parent-child relationship in a program. So we have public class parent. Parent has a name. That's the only attribute that parent has. Parent also has a constructor where we pass in a name and we set the class variable name equal to this parameter. And then we have our getters and setters. All right. So then I create a child class that extends parent. Right. Child now has a name variable as well. Child now has get name and set name methods. But on top of that, we can add additional attributes. So a child would have more style than their parents. And that's what I was going for, whether they have style or not, true or false. So the child has private Boolean style. We pass in that variable Boolean style, and then this dot style equals style. Same thing, except now this child also we can call get name and set name on a child object. And I'll show you that in a second. Before we get there, I want to talk about the super keyword. So inside of your subclass, if we use the super keyword, we're referring to the superclass of that current class that we're in. So let's go back to this example. So it's the same example, except now I'm passing in a string name into this child constructor. Then I pass in that name to my superclass constructor. So when I say super here, I'm referring to the parent of this class, all right? So since child extends parent, when I call super, I'm really calling parent passing in the name. So when I do this, I say Boolean style string name. When I go into this constructor, I'm gonna call super name. It's gonna jump over here, pass in the name, set all these variables, and then keep going, all right? So now we must pass in that name inside of our child constructor and call our super constructor with the super keyword. All right. We could also say super.setName. We can call the superclass variables from within our child class. All right. Let's keep going. And again, when we create an object of a subclass, we can call any methods that inherits from its superclass. All right. So if we have this right here, We create a child. Child C equals new child. True, they have style, and their name is Sean, right? I can call system.out.println c.getName. Now, if you recall, getName is not within the child class. It's inside the parent class. But since this child inherits from parent, it also takes on those variables and methods as well, so that we can call c.getName on a child object, right? So again, with inheritance, when we use that extends keyword, that child class inherits everything from its superclass, right? That subclass inherits everything from the superclass. As such, we can call any methods or any variables that are accessible from a child object, right? So now I'm going to do a coding example, right? So we're going to walk through this example. So at the top of the chain, right, the topmost superclass will be animal. Then underneath animal, we have fish, we have mammal. Within mammal, we have cat, and we have dog, right? So you are more than welcome to do this example with me, but here is the inheritance structure as well. So again, at the top, we have animal, then we have fish and mammal. Underneath mammal, we have cat and dog, okay? Each animal has one attribute, the sex, right? It could be anything, male, female, or any other sex that an animal can have. Then underneath fish, we have species and number of fins. So fish has additional attributes. Underneath mammal, we have bipedal or quadrupedal, which means either it walks on 2 legs or walks on 4 legs, all right? Then underneath cat, we have the breed, and we have whether it's been declawed or not. And lastly, underneath dog, we have the breed again, whether the tail has been docked or not. All right. So let's code this example. New project, Java application, lecture 7. All right, so I don't know what this is. All right, so again, this is our main class. I don't necessarily want to change the main class right now. I want to add additional classes to this project. So to do that, we click on our package, which is lecture 7, right click, new, Java class. Let's start at the top, animal. All right, so we have our animal class. And remember, animal has, I think, one attribute, the sex. So we go back, so we say public, or private actually, private string sex. All right, let's create our constructor, public animal. We pass in the sex. Then we said this dot sex equals to that parameter we just passed in. Everybody cool, clear so far what I'm doing? Just creating an animal class with one attribute. All right. I notice some of your cameras are off. If they are off, you will be marked as absent unless you have told me otherwise. All right. We have public animal.
Is mine on?
Yeah, yours is on.
Because I know it'd be tripping sometimes.
You're good now.
All right.
So again, animal has one attribute, the sex. We pass in that attribute as the constructor. Then next we need to encapsulate this field.
There's tons of ways to do it.
Hey Josh, can you mute yourself, please?
Yeah, that's my fault.
All right, So the first one is to encapsulate a variable, we have to create our getters and setters. So our getter is public void, actually it's not void, public string get sex. All we do is return this dot sex. All right. Our setter is void, public void set sex, string this dot sex equals sex. All right. So again, our animal class has one attribute, which is the sex of the animal. And we have a constructor and then our getters and setters. So you remember this class is now fully encapsulated. Our class variables are private, and we have getters and setters to access those variables and modify them. Okay. The next thing we need to do is, actually the next class I'll create is the fish class. That has two attributes, species and numbers of fins, or number of fins. So new Java class, fish. And if we think back to the relationship, fish inherits from animal. So fish extends animal. Right? So again, how we inherit, we use the extends keyword. All right. Fish has additional parameters, so private, I think species, string species, private, int number of fins. All right. Then we have our constructor, public fish. We want to pass in the string species, int number of fins, and we want to pass in the string sex. So that next, we can call our superclass constructor, passing in that sex. So again, what does this do? When we pass in this string sex parameter, and then we call super passing that in, what we're really doing is sending that to the animal constructor and setting the sex equal to whatever we pass in. Then we can do this dot species equals species, this dot number of fins equals number of fins. Okay, so let's continue. Again, NetBeans has a cool feature that it'll encapsulate all your fields for you. So if you don't feel like writing all those fields, we hit refactor up here, encapsulate fields. Select all, refactor. Now this only really works for primitive types. So strings, integers, doubles. If you have an array or array list, it doesn't work very well because you don't necessarily want to return the entire list. Sometimes you only want to return, one index inside that list or that array. So you would create your own getters and setters for that. But for primitive types like strings, ints, and doubles, that works fine. So now we have all of our getters and setters. So before I go any further, let's test this fish class. So I'm going to read this in from the console. Scanner input equals new scanner system.in. We have to import our scanner. System.out.println. Enter the type of animal you would like to create. All right. So we're telling the user to enter the type. As of right now, we only have two types, just a generic animal and a fish. So 0 animal system.out.println 1 fish. All right. So int choice equals input.nextInt. So basically, I'm telling the user to enter in a 0 if they want to create an animal, or a 1 if they want to create a fish. Remember, a fish is a type of animal, so technically they would be creating one, but if they just want to create a generic animal, we would say enter a 0, a fish for a 1. Reading in that choice, and then I'm going to do a switch statement. Switch on choice, case 0. So this would be if they want to create an animal. System.out.println enter the sex. All right. How do I want to do this? Yeah, enter the sex. And actually, I have to do this every time, so that's all right. I'll do this way. Animal A equals new animal. And I pass in input.next. All right, so basically I'm reading it in from the console. Break. The next case would be a fish. The fish still has the sex, right? So I need to read that in. This time I'll say string sex equals input.next. And I'll say system.out.println enter the species, string species equals input.next, and system.out.println enter the number of fins. Int number of fins equals input.next int. All right. We create our fish object, f equals new fish. I think it was species, number of fins, and then the sex. Yep. All right. So basically, I'm creating two different objects, right? One is a general animal object. All it has is the sex. The next one I'm creating is a fish object, right? However, a fish inherits from animals, so it's going to have the sex as well, but it also has additional attributes such as species and number of fins, right? So again, since fish inherits from animal, it inherits everything, including the variables and the methods, but then we can add our own unique attributes to it as well. And you'll see on Friday that we'll be doing the automobile class, and we'll be creating subclasses from there as well. So you'll actually do this in the lab on Friday. All right, so from here, I want to just print out everything. System.out.println f.get sex, system.out.println f.get species, system.out.println f.get number of fins. Up here, we only have one attribute, so system.out.println a.get sex. All right. So if you look here, what I'm doing is prompting user for the sex of the animal. Then right here, I am creating an animal object. And down here, printing out that object's attributes using the getter method. All right. Again, this is the importance of comments. So you can see, whoever's coming along can see what you're doing. Right here, prompting the user for the sex, species, and number of fins. Creating a fish object. And then printing that object's attributes using the getter methods. So now let's run this. So our program asks me, what type of animal do I want to create? Let's just create a generic animal. Enter the sex. I'm going to say male. And it prints back male. All right. If I run this again, I'm going to create a fish object this time. Enter the sex, female. Species, bass. And number of fins, I have no idea. Let's say 6. And you see, a fish, it has sex, it has species, and fins. So it inherits from animal. Inherits sex from animal. So on and so forth. All right. Does that make sense so far?
Yeah, it makes sense.
Again, inheritance is a pillar of object-oriented programming, and it's one of the most important concepts that you can learn for programming purposes, all right? Because in programming, you'll have many different classes that have, that inherit certain characteristics from another class. It can inherit from multiple classes, right? So in these examples, I'm not showing you that, but I can inherit from several different classes if need be. There's that type of relationship between the classes. All right, let's create the mammal class. Java mammal. Mammal has 2 attributes: private Boolean bipedal, meaning that it walks on 2 legs; private Boolean quadrupedal, meaning it walks on 4 legs. Public mammal Boolean bipedal, Boolean quadrupedal, and string sex, because mammal inherits from animal, and our animal class has sex. And so this is going to give us an error until we actually call our super constructor, and that error goes away. So we have to call that super constructor, or we're going to have an error. This dot bipedal equals bipedal. This dot quadrupedal, quadrupedal. All right. And again, we can encapsulate these fields, select all, refactor. Bipedal, quadrupedal, quadrupedal. Cool. That works. So now let's create our cat class. New Java class, cat. And if you remember, cat inherits from mammal, which in turn inherits from animal. So we would say cat extends mammal. So because mammal inherits from animal, cat is going to take all of those attributes as well, all the way down, all the way from animal down to mammal down to cat. It's going to take all of those attributes as well. Cat has some other attributes: private, string, breed, and private Boolean declawed. Create our constructor, cat, string, breed, Boolean, declawed. And since our mammal constructor has all of these, we need these as well, or we would pass empty values. So I need all of those. Inside of our cat class, we could call super, which is mammal, passing in those attributes, bipedal, quadrupedal, and sex. Again, we're calling our superclass constructor, which for cat is mammal. So we go back to mammal. The mammal constructor takes 3 attributes, bipedal, quadrupedal, and sex. Therefore, in cat, we have to pass those 3 attributes as well. All right. Then from there, we would say this dot breed equals breed, this dot declawed, and then we encapsulate our fields. Right. So now our cat class is done. And our dog class will be very similar, except instead of declawed, we have docked, which is if the tail has been docked. So I'm just going to copy our cat class, rename it dog. Instead of declawed, I'm going to refactor, rename docked. So I just rename that variable, and now we have our dog class. I think I have to change these down here. Is docked, and then set docked. All right. So now we have all of our animals. We have our animal, we have our cat, dog, mammal, fish, all those different animals. So now here I could add in additional animals. System.out.println 2 for mammal. System.out.println 3 for cat. And system.out.println 4 for dog. All right. And then we would read in our choice and then have all the different case statements down here for these different types of animals. So let me type those real quick. It's going to take us a second. Case 2. We have the sex. For mammal, it's the sex. Mammal also has quadrupedal and bipedal. All right, so I'm just going to copy those, enter the bipedal, actually is bipedal, is quadrupedal. It actually doesn't like that, so I'm going to put this up here. String sex equals empty string. So I can use it throughout. Here, this is going to be Boolean bipedal equals input.next Boolean quadrupedal equals input.next Boolean as well. And we can create our mammal. Mammal M equals new mammal, passing in the sex, bipedal, and quadrupedal. All right. Apparently, I'm getting there. Let's see. I think actually sex is last. There we go. So we create a mammal class, a mammal object. All right. And I'm going to print out all these attributes as well. M dot get sex. M dot get something wrong for a mammal class. Oh, is. M dot is bipedal. And M dot is quadrupedal. All right, so that's our mammal. Break. Case 3 would be for cat. And remember, cat inherits from mammals, so all of these are going to be pretty much the same, except we're going to have additional attributes. So instead of mammal right here, we're going to say cat. Cat C equals new cat. And there are other attributes for cats. So for example, a cat has the breed and the declawed. Enter the breed. Is declawed. Here is the breed, string breed equals input dot next. Pass in breed, declawed. Then we pass in bipedal, quadrupedal, and the sex. And we can call all of the same methods because cat inherits from mammal. Except cat also has 2 additional attributes. C dot get breed and C dot is declawed. Then our last one is the dog, case 4. Dog is last. Dog is very similar to cat, except the only difference is instead of declawed, docked. We'll say dog D equals new dog. Change all these C's to D. And declaw to is docked. So now we have our full example. If we run back through this again, animal is at the top. Fish inherits from animal, so it inherits the sex. Likewise, mammal inherits from animal, so it inherits sex. But mammals also have other attributes such as bipedal and quadrupedal. Cat and dog both inherit from mammal. So cat and dog then have sex, bipedal, and quadrupedal just from that inheritance. But then the cat adds the breed and is declawed, whereas the dog adds the breed and is docked. All right. So now I can run this. It asks me for what type of animal do I want to create. If I create just a simple animal, so a 0, all it has is the sex, male. However, if I create a cat, cat inherits from mammal, which in turn inherits from animal. So it's going to have the sex, so I'll say female, is bipedal. Cats are not bipedal. Is quadrupedal, yes. The breed, I'll say, I don't know too many cat breeds, but I don't know, random. Can't think of one off the top of my head. Yeah. and is declawed. We'll say true. And you see cat has all these different attributes. Sex, I don't know why it's printed out true first. Let's see. Get sex. Let's see. Well, I printed out the sex, the is bipedal, random, and true. I don't know where that true came from. Somewhere in here. Somewhere in the code. But regardless, so the cat has all the attributes of an animal, all the attributes of a mammal, plus additional attributes of a cat. Same thing with dog. 4. Dog has all the attributes of animal, so sex, all the attributes of a mammal, so bipedal or quadrupedal, plus additional attributes, so has the breed, pit bull, and is dog. See, I don't know why there's, oh, I know why. I put a space in here. So breed input dot next line, input dot next line for the breed. That way, if I put a space in there, it'll read that space. So dog, if we go back through all the attributes of animal, all the attributes of a mammal, so it's not bipedal, it is quadrupedal. Enter the breed, it's just messing up. And is dot is, let's say, false. All right, so there we go. There's our full example. And I would have to fix this next line. For some reason, it's reading in a line, which I haven't put one yet, but there we go. There's the full example, and that kind of gets the gist of what I'm talking about. Again, when you inherit from one class, it assumes or takes on all the attributes, including the methods and variables of the superclass, which goes all the way up. And in programming, the topmost class that every object you create, every object that you use inherits from is called just the generic object class with big O, object. That's the topmost superclass of everything out here, even the ones that you make. Everything inherits from object. Object has a couple of built-in functions that you don't ever really see or use, but no, that is the topmost class. That's just for your information. All right. Any questions, comments, or concerns, or areas for clarification? Again, encapsulation and inheritance, those are the two keywords that we've covered so far, and 2 of the 4 pillars of object-oriented programming. That is imperative that you know and how to use those concepts. So if you don't understand them at this point, let me know soon so that we can tackle that early instead of later. Lastly, your attendance on Fridays is critical to your grade. That's the one time of the week you have the opportunity to ask me questions and I can answer them like that in class. So I stress to you all who haven't been coming to class on Fridays to come to class on Fridays. If there is a physical barrier or some other reason that you are not coming to class and that I don't know about, let me know. But again, I stress to you all, and it's to your benefit to come on Fridays. All right. So hopefully I see you on Friday and we can cover these concepts in the lab. All right. That'll do it for today.